Dear students, welcome to the knowledge series. Here we are going to discuss on real-time operating systems. Along with that, Micro C operating systems and VxWorks operating systems is also included. This is the part of module 6 of EC 366 of real-time operating systems. The entire discussions we have put on in the video series, where you can see that the first we will go discussing on the operating systems, followed by real-time operating systems, and then VxWorks and Micro C operating systems will be discussed in these segments and the subsequent segments also. So we start with the basic concept of the operating systems. Now, what the operating system means? We have discussed a lot about the operating systems in the earlier video series, so you can go through that. However, as a part of the discussions, we will be going as per the slide. The operating systems is an essential components of every computer systems, and the computer systems it cannot functions without the operating systems. Therefore, a computer systems once it is when it is powered on, the CPU first task is to load the operating systems. So what is the operating system? It is an interface between the user and the hardware. So this is the user and this is the hardware. So between the user and the hardware, this interface is termed as a operating systems. So when the computer system is powered on, CPU first task is to load the operating systems, and the computer system become fully operational to the users. Only after the operating system is loaded in the main system memory. So that is very important. So loading the operating system is not the complete task. Once it is loaded, once it is booted, then it becomes functional when the operating system is loaded into the main system memory. So a computer system, once we split into components, we will say that it is having a two part. One is hardware part, and that is and another is a software part. And hardware part, what are those? CPU, memory, hard drives, all these things is coming in the hardware. And the operating system, depending upon the user which they are using for the system, Windows or Apple OS or a Linux type of operating systems. And the end users is the user that runs the applications over which what they are expecting the computer to perform. For example, if the end user want to run a MP3 files, the operating systems will receive that file based on certain steps, and that steps will makes the operating systems to perform based on the use of hardwares. That's how it will result the MP3 files to deliver that outcome in the form of a audio signal from the speaker. So here you can try to see the computer system consists of two main components: hardware components and the software components. The software components, it consists of a system software and the application software. And the application program, it provides the interface between the users that cannot be directly interacting with the hardware components. And when we talk about a system component is called as operating systems. So that is the one which interact with the hardware components. Now there is another things you can see apart from the system components and the application components. There is also another component is called as a driver software. So operating systems will interact with the hardware through the set of drivers. So that's how the operating systems manages all the applications program as well as the systems resources. So whichever the whatever the systems program is to control, those system components is also being controlled by the operating system. So the operating systems is the most important software components in the computer systems, and that provides a necessary resources and the runtime for the various interface components as per the applications for the computer to run and as well as to execute. Now here you try to see that operating systems, it is being shown, the allows convenient usage and allow efficient usage, provide informations protections, gives user slice resource, and acts as a control program. Now allow convenient usage. What is this convenient usage? It means that whenever any user want to run a particular application, say for example you want to run a MS Word or a MS Excel, you don't need to bother about how the computer is performing that files. So you find the systems or the users find it a system is very user friendly. So that's how it allows the convenient for the user to use these particular systems with the help of operating systems, and allow an efficient usage. Efficient usage means you can run more than 2 or 3 applications at a one stretch. For example, you run MP3 files, you run say MS Word, MS Excel, but the system will deliver everything in appropriate time, and also you will find it that whatever you are requesting for the systems to run or the application to run, the execution is very fast. Another is provide the information protections. It provides security protections in the form of a password, and that's how the the form in which one cannot able to alter the informations. That's how the systems protections can also be system protections, hardware protections, as well as the software protections and the data protections. Everything is possible with the operating systems and the applications that run along with that system program. Gives the user a slice resource. So every resources that works at the same time or the systems that can able to run various resources. The computational is so fast that at a one click you can able to see the application executions with the multiple programs is running at a one stretch. So that's how you will find that it is like a slice resource. Slice resources will be there, but the executions you will be finding at a one instant you can able to see the outcome. Act as a control programs. So you can have a multiple program you can able to control with the help of operating systems. Now you can see the quote, world without operating system is like a human without a heart. So operating system is the heart of the computer systems, where the hardware and the other software components are interlinked or are interfaced through the operating systems. Now let's see the history of the operating systems. If you look across the history of the operating systems, the operating systems history is defined, it was first developed in the year 1950s, and this particular operating system was developed to manage the tape storage, and this was done in the General Motors research lab to implement the first operating systems for their IBM 701. That was the computer system. For that purpose, this the first operating system, it was developed by the IBM for the General Motors. Now in the mid 60s, the next operating system started to use a disk. At that time the disk was started moving into the computer field. Way back in 1960s, the Unix operating systems version of the first operating system was developed. Later on, the Microsoft they developed the operating system, and it was built in the year 1981, and the Microsoft it built by purchasing the 86 DOS software from a CTEL company. That's how the Microsoft developed the operating systems. And as on today, you can see the operating window is in highly demand, and that is one of the popular operating systems, and it first came to existence in the year 1985, and it has its own graphical user interface, and it is paired with the MS-DOS. That's the Microsoft DOS operating systems. Now if you look across the operating systems in terms of market shares, so we will find that there are different type of operating systems in the market, like Windows operating systems, Android operating systems, iOS operating systems, Mac OS operating systems, Linux operating systems, and Chrome operating systems. Windows phones is there, so Symbian operating system, like the different operating systems are there. So every operating system has its own market shares. So you can see here in the market share operating system I have shown. Android, it is around 38% is there, Windows 40%, Apple iOS 16%, Mac OS is 4%, other is 2%. So like that distributions is being shown here. Now here also, if you try to see across the Windows only itself, Windows XP is most is 81.94, Vista is there 4.52, Windows 2004, Mac OS like that 3.52. Like this distribution, if you add it, it becomes 100%. So that's how the distribution is being shown over here in the form of a graphical representation, so that one can able to understand that how the operating system is performing in the market, and what are the basic demand of this particular operating system. When we talk about Windows operating systems, automatically you find that the systems works in a different form as compared to the Linux operating system or as compared to the iOS. But anyhow, every operating system is contributing to the various resources, and it runs the almost all the process so that it can be at the par with each other, and depending upon the user's needs, it tries to build up its performance, and it tries to deliver the needs as per the applications and other components whichever is integrated with the systems. Now let's see the next important discussion with respect to these operating systems. We talk about the kernel. Now when we talk about the kernel, one has to understand what exactly the kernel means. Kernel basically it is considered as the central components of the operating systems. That means when we have seen in the previous point of a discussion is that user is there. Yeah, after that application program runs, then operating system is shown, and that after that the hardware. So that is how we are defined the operating system is nothing but the interface between the user as well as the hardware. So that is how we try to represent. But now when we talk about a kernel, we are in the central part of the operating system. You can try to see here. This is the definition of the operating system. It acts as interface between the hardware and the user. But now you see the kernel. Hardware is there, user is there, and the terminal is shown. But here the kernel is resides here, and here is shown the shell. So these things we will be talking. But before that, let's talk about the kernel. Now, as I stated, is the kernel is nothing but the central part of the operating systems, where the application program or user level application programs runs here, and on the hardware side you can see that the processor is there, memory is there, hard disk is there, and various devices is being shown. So this is how this particular kernel is being shown. The job of the kernel is to manage the communications between the software and the hardware. So that means system software is there and the hardware is there. So that's how it will try to manage, and also communicate with the applications level programs. Now, when we talk about a kernel, it is considered as a nucleus of the computer. Now, when we talk about operating systems, it is the heart of the computer systems. Now, kernel becomes the nucleus. So it is the central point of the operating systems, and its duty is to make a communications between the hardware and the software. Now, when we talk about the shell is basically the outermost part, and the kernel is nothing but the inner part. Inner part. Now, the shell is basically an interface between the user and the kernel. That you have to keep it in mind. Shell is direct interface between the user and the kernel. So, it is a command line interpreter. Now, shell is basically a command line interpreter and is the interface between the user and the kernel. Now, here what happens is the user can enter the commands to the cell, and then the shell will try to interpret the command and performs the task what the user requested, or whatever is the required task. Furthermore, it tried to execute the program, and that program it will be in the cell script. And a cell script, when we talk about the cell script, is nothing but a set of command. So here user try to follow the standard syntax and write the command to the cell. That's how the cell tried to communicate with the kernel, and through the kernel it tried to directly interact with the hardware components. Now, as the things about the kernel and cell, as I have stated, in another word, we say that the kernel basically, when we want to run a critical code for the kernel, it has to store in a special memory area, and that area need to be protected from the other programs, so that it will not be get corrupted. So it is a vital component, and it's it needed a proper functioning so that entire system will become work in a appropriate manner. So that's why the protection of the kernel is very essential. The kernel performs a varieties of tasks. like a process management, uh, uh, memory management, file management, like that. Many other activities, interrupt management, like that. Many activities this kernel try to performs. So that's how these are nothing but the basic essential duties of the kernel. Now, if you see the right side on the on this slide, you can see that there are various functions of this operating systems. So as I stated, that operating systems try to interact with the hardware as well as the users. So in the functions of the operating system, if you try to see, one you can see the memory management, process management, file management, device management, input output management, secondary storage management, security, command interpretations, networking, communication management, job accounting, like that. Various activities it has been put. Now when we talk about process management, what exactly is the now process management? It tries to help the operating systems to create and delete the process. When we talk about a word process it is nothing a program in executions. When we write a program and it is, if it is completely executed, then we term it as a process, or we term that the process is nothing but a sequence of steps that performed by a program based on computers, and that's how the computer carries that task. And when we talk about a task is nothing but a process. So a program plus data is we termed it as a task, or in another word we say that a set of tasks which is performed by the computers based on the executions in an appropriate manner is termed as a process. So here in the process management, the operating system tried to create and delete the process. That is how, and that's how it provides the synchronizations and communications between various processes. Next, we talk about a memory management. Memory management basically it is to perform a task for allocations or deallocations of the memory space for a programs. As you know that from the secondary memory when it comes to the primary memory, or from the allocations of the memory space in the secondary memory or in the primary, all this management is carried by the operating systems, which is a part of this kernel. File management. When we talk about a file management, it manages all the file related activities, such as for storing, organizing that particular files, retrieval, or naming the file, sharing, or protection of the files, all these things. Next, device management. Device management basically tries to keep the track of all the devices, and it's responsible is that whatever the task is there, it should be able to execute through the input output controllers. And that means the responsible for the device management is to see that input output control can process that particular task, and it also performs the task of allocation and deallocations of the device. So that also it will try to carry out. Another is the input output system management. One of the main objective of the operating system is to hide the hardware from the users. So that's how the input output operating system carries out, and moreover input output activities like printing activities, like scanning activities, giving keyboard inputs, all these things is being managed by the input output management. And secondary storage. Secondary storage is whenever the system want to store in the primary or in the secondary memory or in the cache memory. All these instruction and datas on the for the storage in various locations, whether it is a primary or in the secondary, it is being carried out by the secondary storage management systems. Security. Security model is to protect the data and informations of a computer systems from threats, malware threats, or unauthorized access. Then we see the command interpretations. Command interpretation is that basically this particular section is for interpreting the commands given by the system resource to process the command. Suppose if a user is giving certain commands, how the command is being processed by the shell through the kernel, that's how the operating system will try to see that command interpretations section will try to process that particular system command based on the resources that it is requesting for. Networking basically, for example, a distributed systems with a group of processor want to share the common memory or the hardware. All these things is being controlled by the networking. So a processor can communicate with other computer through a wired network or in the wireless network is based on this particular networking unit. Another is communication management. The system here, the computer systems can coordinate with respect to the compiler interpretations, compiler interpreter, and also various softwares that is being run across the application as well as the users, as well as the device driver sites, so that the systems can able to communicate efficiently with the help of the operating systems. And finally, in the job accounting is that it keeps the operating systems keeps the track of the time and the resources used by the various jobs and users. And job means nothing but it's a collection of or a set of process. So that is what the particular job accounting it means. So this is what exactly I want to express with respect to the kernel. Now we go to the another very important area is the kernel types. Now there are two different types of a kernel which you can see in this figure. The most popular type of a kernel is microkernel and monolithic kernels. You can see this figure. This is a monolithic kernel and this is a microkernel. Where you can see that on the top part, you can see this is the top part. The top part is the user mode, and the intermediate part, it is nothing but a kernel mode. As I have stated to you in the previous figure with respect to the various function of the operating systems, that is what we can see in these particular sections with respect to the monolithic kernel and the microkernel. In the microkernel, basically what exactly the microkernel is that it's a software, or we can say that it is a program in which user service and the user is here, and the kernel service is being present in a different addressing space. You can see this one. Here is applications, IPC is there, Unix server is a device driver, is a file server is there. All these different resources is having a separate address locations, and this is nothing but a virtual memory, and here and this particular section is nothing but a kernel space. So here in this kernel space you can try to see that the operating system or a microkernel is resides, and the microkernel section it try to manage all this one as I stated to you. These are nothing but a system resources. It try to manages all these system resources, and every system is having a different address space. So whenever a user service is stored in the user address space, and the kernel service is needed. So in that case, the kernel service will be having a separate kernel address space. So this particular section is a user space. So as the user has a separate address, accordingly the kernel space service will be also having a kernel address space. So you can try to see this one is the kernel space is reduced in this case for the operating systems, because this is the only space for the kernel space, and where everything is being sitting together. So that is the things which are with respect to the microkernel. And moreover, microkernel is easily extensible, because you can keep on you can add more number of resources over here. That is what I talked about in this particular sections with respect to the various functions of the operating system. So all these functions can be put across this place. So this is what exactly means microkernel. And if you see the different type of a microkernel, like a Windows Nokia phone, Symbian OS, or a Mac OS OS X, or your L4 Linux, all these things coming under this particular microkernel. So this is what I want to talk about the microkernel. Now let's see about a monolithic. Now when you try to see in the case of a monolithic has a set of layers with respect to the kernel modes. You can try to see. Now here in the monolithic kernel, basically it is a program where you can have a kernel service and a user service in the same address space. Here we are having a different address space, but here we are having a same address space. But here when we are having a different address space, the space is occupied by the common kernel space. But here we are having a single address space, but the kernel space is being distributed for individual independently. So but here it is common for all. So that is what I mean to talk about. Now here it makes the executions of the monolithic kernel much faster because of as compared to the microkernel. And the size of the monolithic kernel here in this case is larger as compared to the microkernels. That is what you can try to see over here. Moreover, the monolithic kernel you cannot go for further extensions as you can see here. Here you can do, but here it is fixed because the user service and kernel service are present in the same address. So in order to add any other service, the entire kernels you have to modify. So this is one of the major drawback in the monolithic kernels. So some of the example of the monolithic kernels, if you want to see it, you can see the Microsoft Windows, Linux, Solaris, DOS. These are the some of the example of the monolithic kernel. Now when you try to see across the kernel type here, I have distributed here with respect to size, execution, extensible, security code and example. Microkernel is smaller in size, whereas monolithic larger in size. Execution here, it is a slow execution because different address. Here it is a fast execution, and here you can go for extension. Extensible is possible, but here it is hard to do. Security in this case is that you can find that if the service crashes, it does affects the working of the microkernel. And here it is if a service if something happens, the whole systems is affected. But here certain systems will so it is more reliable as compared to this one. Now to write a microkernel code, here you have to write, since different address, more code you have to write, whereas here in this single address you need a less codes. Example I have given: Symbian, QNX, L for Linux, etc. And here we have seen the window is there, and Solaris is coming, and Linux, BSD, all these things is coming under the monolithic kernel. Now we will see the another sections with respect to the area is with respect to the process. Now what exactly this particular process indicates. Now to understand this particular process and its further discussions, we will be seeing in the next point of our discussions. Thank you.